Charan, thank you so much for joining us today here at the Royal Institution, and congratulations on your new book, Why We Remember. For those of you listening or watching, by the time this is released, the book will be out. So if you haven't read it yet, this is your official reminder to do so. Your book and your research focus particularly on what's going on in our brains to facilitate our memory all the way down to the cellular level, and how we can use it more effectively. What inspired you to get into this area of research and write the book?
Well, one of the things that really inspired me was when I was in graduate school, I was doing clinical psychology. And many of the people that I was working with were worried that they had brain damage, or they were referred by a doctor or sometimes even a lawyer. And we would do testing with these patients. And what I would find is that whatever the disorder it was, whether it was something like, pre-Alzheimer's disease to traumatic brain injury to even things like clinical depression, we would see that memory was affected. It was the first thing to go. And at the same time, I was doing clinical work in psychotherapy and finding that the patients that I was working with, they had the opposite problem of too much memory, and they had these traumatic memories that they were trying to work through. And so it really became apparent to me how important memory is. And at the same time, I also felt that we didn't have a very strong scientific basis for understanding how to treat memory problems. And so at that time, functional MRI, or functional magnetic resonance imaging, was this technique that was getting off the ground as a way of looking at people's brains and being able to see what areas of the brain are actually doing things in relation to memory. And so I jumped on that opportunity.
So you've already mentioned memory underlies basically everything we do. It's our behavior, relationships, careers, and we're all learning from the experiences that we've had, and we're retaining that information. But it's also something that a lot of us do take for granted. You've mentioned that some people have problems with it, and it's also quite complicated. Could you give us a bit of a whistle-stop tour of our current understanding of how memory works?
So it's such a big topic. I'll try to reduce it to a few key points. But one of the key ideas is that memories are thought to be stored, so to speak, through connected networks of neurons, which are the basic cells that are doing the computing in the brain. And so what we think happens is when you speak, when you feel something, when you see something, there are groups of neurons that are activated that allow you to have these conscious experiences, or even unconscious experiences, things like your heart racing when something scares you. And so when we have these experiences, there are changes in the connections between these neurons. And so that's what you'd call plasticity. And those changes allow a group of cells that were active during an event to become more easily activated again later, even when that event isn't taking place. So if I could activate some of the neurons in this cell assembly, is what we call them, from this conversation, presumably through these strengthened connections, the other neurons could be brought into play. And so it only takes me a small cue to be able to pull up the entire network of neurons that are part of this memory. So that's kind of the very whistle-stop tour, I guess, but then you can certainly go deeper than that into all the different kinds of memory and the way it works.
So we've got, I'm going to keep it very basic, even though it's very complicated, but we've got short-term memory, long-term memory, and different types of long-term memory. Could you give us a bit more about that?
In memory research, we like to cut things up and say this is different and that's different. But in reality, when we remember an event, for instance, it's all very connected. One of the key distinctions that I've really been working on throughout much of my career is the distinction between episodic memory and semantic memory. So semantic memory would be your general knowledge about things that you've acquired over the years. And episodic memory would be your ability to remember a singular event, whether it's an event that's mundane, like I'm in the kitchen and I'm trying to figure out, wait a minute, why am I here? And we could talk about other kinds of episodic memory, like where did I put my keys, to I'm vividly remembering my 16th birthday, or I'm trying to remember that later on I have to take out the trash because it's trash day. So all of these kinds of memory are related to episodic memory. And we know that there's a brain area called the hippocampus that's very important for episodic memory. So people with damage to this area, they can still walk, talk, think, but they have an exceptional problem being able to remember things related to a time and a place. So there's many famous patients, including some that have been described at University College London, who can learn information, but they don't have this ability to re-experience it and tie it to a context in the way that somebody with a hippocampus can do. And so what that tells us is that the hippocampus seems to be organizing and associating our experiences. So it's getting information about who was in an event and where the event took place and how things transpired, what was the situation, what were the feelings that we experienced at the time. And it's associating them all, and it's just putting it together just because at this moment in time, all of these things happened. At this moment in time, I was excited to tell you about memory. And at the same time, you were here. And at the same time, I'm sitting on these purple chairs or whatever this color is, right? And so all of those bits are being put together by the hippocampus. And what that allows you to do is some other time, if I walked into this room, that would be enough to cue me to be able to allow the hippocampus to pull out all the other bits that happened in this past event. And so that's why, for instance, if you end up in the kitchen and you're trying to figure out, well, why am I here? You actually have to pull up information about that past context when you decided you were going to go into the kitchen in the first place. And so I then essentially engage in what Endel Tulving, the psychologist who came up with this term, he called episodic memory as mental time travel. And the idea is that you have to go back in time mentally and be able to say, hey, wait a minute, okay, I'm here in my office, and I realize that I left my phone in the kitchen, and that's why I'm there. And so otherwise what happens, and this often happens to me, is I end up in the kitchen and I forget why I'm there, and then I end up just eating something. And then I come back and then I realize why I went to go there in the first place. But being able to visualize that context, the place and time, really helps. And in fact, we've, and many others have done research where if you scan people's brains while they're experiencing an event, and then you scan them while they remember that event, what you can see is this little bit of a reset in the patterns of activity in the hippocampus, such that it looks more like what it did in the past. So these patterns change a lot over time, but when we remember, you can reverse those effects of time. So it's almost like being in a time machine, essentially. You're going backwards in time. And one of the fascinating things about this is that as a result, we can actually change the past when we remember. So we tend to think of memory as being just a replay, like you would play a movie on your phone. But in fact, the act of remembering a past event can lead to changes and updating in the memories. And this has been shown in everything from rats and very simple kinds of memories to humans and much more complex memories.
So for me personally, and I know it happens to a lot of people, there are certain like smells and songs that bring back very specific memories that I didn't realize I had. Why does this happen?
Well, one of the things that I think people don't realize is that sometimes a memory isn't forgotten, but we just don't have the right way to access it. And so when we hear a song, for instance, that comes out of the blue, and it just pops this memory of a particular time back in our head, often it's the case that that song was a particular soundtrack for us and during a particular period in our life, and it evoked a particular emotion. And so as a result, they're baked into the context of these episodic memories. And so they provide this beautiful way of accessing memories for a time and a place. So sometimes we've had sad periods in our life and you listen to sad music, or you have periods of time where you just decide to get into electronic dance music, and then you go through a classical phase and so forth. And those songs that are associated with particular points in our life tend to be the ones that are the best retrieval cues to pull out these once dormant memories. And but it's not just, of course, music. Smells can do this. Being in a particular place can do this. As long as there's some kind of a context that is unique, it will help us access those memories.
So lots of memory tips and tricks out there. One that I've heard is that if you revise for a test in the same place that you're going to take the test, those memories should come flooding back to you. Does that work? And if so, why? And if not, what are the other memory misconceptions that are out there?
Well, I think it can work if you're not using good study habits in the first place. So if you're really just have this unique memory of having studied something once, then being back in that same seat and looking at the same scenery can help you pull up that information that you studied just once. But ideally, what you want to do is take advantage of the fact that memories update when we remember in different contexts. So if you study, or even better, if you test yourself on what you've learned, let's say in this room, and then you go home and you do it, then you go to your favorite cafe and you do it, what happens is every time you recall this information that you studied, now what happens is it becomes updated, so it's not tied to this one place. It can now generalize to different places. And at some point what happens is that the memory for the information you need is accessible anywhere. And so ideally what you want is, you don't want to have to be sitting in one place to remember everything that you're trying to remember. You want to be able to get it from anywhere else. And so I think one that you mentioned, a memory misconception. I think one misconception is that if you read the same thing over and over again, and then you take the test in the same spot or whatever, that you're going to retain this information. And it's just not true. Actually, you retain much more information if you force your brain to struggle. And so by that, I mean that you try to test yourself. And sometimes you can even test yourself before you study, and that can actually enhance memory too. And so this is a method that I talk about in the book called error-driven learning. And the idea is that when you actually force yourself to try to pull up information from memory in challenging circumstances, what happens is when you do get the right answer, essentially there's changes, we believe anyway, based on our computer models of the brain, that essentially there's parts of a cell assembly that gives rise to a memory that are not necessarily very helpful and adaptive, and there's some that are very, very effective, right? So what happens is that the memory can get reconfigured and tuned up so that the bad connections go and the good connections are strengthened. And that only happens, though, if we allow ourselves to be stress tested in the first place.
So even though there is a long way to go to understanding neuroscience, we have come a remarkable way, but there is a lot of progress that we need to make. We are also sat in the Royal Institution in the theatre where the Christmas lectures are filmed. So I thought I'd go over a couple of Christmas lectures that we've had in the past that are based on neuroscience and memory. So we've had Richard Gregory, who gave his lectures The Intelligent Eye back in 1967, which was the first Christmas lectures ever broadcast in colour, and only the second ever broadcast on BBC Two. We've had Susan Greenfield delivered the Christmas lectures in 1994, titled The Journey to the Centre of the Brain. So that's quite fun. And then the most recent one is Bruce Hood, who in 2011 delivered the series called Meet Your Brain. How have you seen the understanding of memory and neuroscience develop over your career?
Well, one of the big developments that I've seen over my career has been the ability to move away from thinking that memory is just one brain area to really thinking about networks in the brain and how they interact with each other. And so because before brain imaging was really big, people would focus on specific areas of the brain, like the hippocampus. But now one of the things we appreciate is that memory is more than just the hippocampus. It's just that some areas of the brain, it's harder to find disorders that affect it. So for instance, there's a whole network of brain areas called the default mode network. And people used to think this is just a network that comes on when you're not doing anything. And now we realize it's actually exceptionally important for memory. And if you look at the pathology in the brain that happens over the course of Alzheimer's disease, the hippocampus is part of the, ground zero, but then soon after you start to see pathology throughout the whole default mode network.
You mentioned Alzheimer's disease. So obviously we've got neurodegenerative diseases that are marked by memory loss. What goes wrong to cause these memory dysfunction?
Well, it's still under debate, but one of the ideas that's out there is that brain areas it's not like you can go to any part of the brain and find connections to every other part of the brain, right? It's just like if I go to a tube station, there's certain lines that you can get onto, and there's other lines which aren't really connected to each other. And then there's some lines that are there's some stations that are hubs where you can transfer from one station to another. And you can think of the brain in a similar kind of way, that there are these networks of highly interconnected neurons where if you're on one part of the line, it's very easy to get to another part of the line. But then there are some networks where the between network connections are very weak. And so what that means is it allows the brain to both be specialized, but at the same time, it gives some flexibility to allow areas of the brain to talk to each other. Now, one of the consequences of this is if there's pathology, like the buildup of toxic proteins like tau, for instance, that what it can do is you can get this spread from one neuron to another. And so that can cause an entire network to basically collapse when you have the spread of a neurodegenerative disease like that.
And your team at UC Davis are working on ways to catch signs of Alzheimer's earlier and try and prevent damage before it starts. How does that work?
Well, so there's many different approaches that are being tried out right now to catch the pathology very, very early, because one of the big discoveries in Alzheimer's research was that you can actually start to see heavy buildup of this protein called amyloid, which is thought to play a part in the whole cascade of events that causes the brain damage in Alzheimer's. And if people were trying to do drug discovery, what they would do is they would try out these drugs in people after they've been diagnosed with a clinical memory problem. But now we know that by the time someone has a memory problem that's easy to detect, what they find is that there's already pretty significant loss of neurons, and you can't really reverse that. So if you want to come up with an intervention, you want to be able to intervene before that brain damage really kicks in. And so now we realize there's this long preclinical period. And so one approach that's being done is to look at blood plasma tests, and that looks very promising. In our lab, we're hoping to develop behavioral tests that any neurologist could give, so that there's different ways of identifying people in these early stages. And so one of our lines of research is focused on this interaction between the hippocampus and the default network. And we've got good data now from a very large group. It was 346 people scanned, actually in the University of Cambridge. And we analyzed that data and found that there are these certain points when people are, say, watching a movie, for instance, where the hippocampus seems to come online, and that's related to memory and the default network too. And these activations reduce as people get older. But what's interesting is that independent of age, people with poorer memory performance show less of this variability in the hippocampus. And so what that tells us is that we can use these as biomarkers for memory problems, or biological markers, so to speak.
So keeping on the theme of looking into the future and future research, we get this question a lot on, artificial intelligence is a big topic. We've just had the 2023 Christmas lectures on it, and it's being integrated into society more and more. So how will artificial intelligence impact our memory, or is there any concern around that?
Well, there's many different kinds of concerns. What I would say is certainly one issue that I worry about is what you can see with a lot of the issues that come up with technology in terms of our thinking and our memory functions are not really related to the technology per se, but the way we interact with it. And so one of the things that I think about quite a bit is now, for instance, with this actually happened a few years ago when I would start using email programs. They would use AI to finish my sentences. And about 1/3 of the time, I would say, no, this isn't what I want, and just type it myself. 1/3 of the time, I'd say, this is exactly what I want, just fill it in. 1/3 of the time, I'd say, that's good enough. Let's just go with that, because I didn't want to type the rest of the sentence, and it's not what I would have wanted to type, but it goes anyway. But the brain, as I said, is very plastic, and it's constantly reorganizing to be more and more efficient. And so as a result, what happens is that often people can start to just learn to adapt exceptionally well to whatever is being suggested to them. And the downside of that is that people can actually become less creative, and you might end up just sort of seeing this like funnel towards mass mediocrity. Essentially, if everyone, it's not that ChatGPT would write what you want. It's more like everyone would start writing like ChatGPT.
I hope that doesn't happen.
I hope so too. I hope not to.
So you mentioned the potential lack of creativity. How does memory help us be creative?
So memory is incredible in humans because we do things that are very different than typical generative AI systems. So generative AI, they just absorb massive amounts of data and then try to find patterns in it. Humans actually take in very weird kinds of data. Like we don't even see the entire world in front of us. We just get little snippets of the world by moving our eyes around. And so as a result, we actually put together much more rich kinds of inferences for much less information. So you wander around the world, you meet people. Maybe when you're in uni, you lived in a dormitory with friends who you wouldn't have met if it just didn't happen that you were living in the same place. And these kinds of unique experiences, somebody gives you a book for your birthday and you read it, and it's something completely outside of your normal experience, you can start to build connections between ideas. And if you look at some of the great artists, some of the great musicians, poets, they're actually people who took a diverse range of influences from their lived experiences and just found unusual connections between them. And this is the kind of thing that we can do because of episodic memory. Episodic memory allows us to take these unique moments in our lived experiences and then recombine them and put them together into new things and synthesize them. And this would be something that is not present in at least current AI systems because they're designed to just take the common elements of whatever they're trained with, as opposed to the distinctive, unique, weird experiences that we have.
And also in your book, you mention, to me, in the same thread, imagination. How does memory help us with that?
Well, so one of the early memory researchers that's been just a huge influence in the field was Frederick Bartlett, who was actually at the University of Cambridge. And Bartlett proposed a really radical idea, it remains radical to this day, that essentially we don't remember the past by replaying a video in our heads, even though it feels like that. We actually only get little glimpses of those past experiences. So we don't activate the entire set of neurons that were part of an event. We actually just get little bits and pieces. But then we're able to use our knowledge and use our goals and use everything that we have to build a story and imagine how the past could have been. And that's the act of remembering. And so this is why there's this just amazing link between memory and imagination. So for instance, a number of researchers, including Demis Hassabis, who started Google DeepMind, and Eleanor McGuire, discovered that many patients who had memory problems also had a very impoverished imagination. And when people started to scan brains while healthy people were just imagining, or healthy people were remembering experiences from their own lives, what they found is that basically the same networks of brain areas in the hippocampus and the default mode network come alive. And so there seems to be this element where imagination is the core of memory, but also memory is the core of imagination. That is, if you have a memory problem, your ability to think about, to imagine how things could be in the future, or even imagining the present. And I know that might sound a little weird that we can imagine the present, but one thing that we're doing in this conversation is we've got this common ground because I have some understanding of what you are asking me that goes beyond the simple words that you put out, right? And memory is very important for being able to connect those dots. And that kind of ability to use memory flexibly to generate in things that aren't in front of us is exceptionally important for imagination and for creativity. But it also creates some huge problems because we have a very hard time telling the difference between things that we imagine versus things that actually happen. So I don't know about you, but I often have cases where I get an email and I think, oh yeah, I've responded to that. And then a week later, it comes back and it says, urgent, please reply. And I realized that I didn't respond to it. I just thought about it. And then I said, oh, this is how I should reply. And then I got interrupted and distracted and I never did it. And so we have this real challenge of being able to say, is this something that I thought about or is this something that actually happened? And sometimes people can actually get so far out in this that they can remember events that never actually took place if they imagine them too vividly.
So I'm sure that everyone listening to this or watching this podcast episode has one thing that they can never quite remember. It's at this point that I'm meant to say one thing that I can't remember, but ironically, I can't actually remember what I can't remember. So we're going to move on. And one of the themes in your book is how we can use our memory to our advantage and more efficiently for all our sakes, especially mine. What's the secret?
I think the secret is you have to first accept the fact that memory is not supposed to be an effortless process where you can record every part of your experience and replay it exactly as it happened. I think a lot of people start with this assumption that it should be effortless, it should be complete, and it should be 100% accurate. And when you start with those assumptions, you're going to make mistakes. And that's in some sense normal, but in another sense, it won't help you remember the things that you want and remember it well. So we know that the information that tends to get forgotten is suffering because memories compete with one another. And this is one of the many ways in which the human brain is different from machine intelligence, where we really store many memories with overlapping assemblies of neurons. And so what happens is that activating one memory can actually compete with or inhibit another memory. So if you take the kinds of things that happen every day, like, I put down my keys and then later I'm saying, where did I put my keys? It's a very difficult problem because you have memories of where I put my keys an hour ago versus 3 hours ago versus 1 day ago versus 2 days ago. And so it's not a matter of just remembering where I put my keys, but finding the right memory of where I put my keys. That's the issue. So how do you beat that interference? One way you can beat that interference is by, first of all, capturing and paying attention to what are the important features in your environment. And that sounds very easy, but it's not, especially in the world we live in. People are always being bothered by text alerts and so forth. We're often doing one thing, but engaging in all sorts of mental simulation and planning for other things that we're supposed to be doing, and actually engaging in a lot of memory processing, thinking about the future, thinking about the past. And so that really distracts us from the present moment and makes it so that we're not even there in the first place when you put down your keys. And we know that the kinds of memories that really benefit and are able to come up at a moment's notice are the ones where we have a lot of sensory detail, for instance, just vivid information about the sights and the sounds and the smells and the emotions that make a memory distinct from other memories that they could be competing with. And so anything that you can do to focus yourself on those moments that make an event unique will help you remember what you need to remember. And I think part of what we need to do is actually go ahead and think about, well, what do we want to remember in the first place? Because if we're not going to remember everything, then the question is, what do you need to remember? What do you want to remember? And how do you want to remember it?
So we've covered how we can access memories with unique events and different senses. But there are obviously some lifestyle choices which lead to memory loss. For one, the consumption of alcohol. Why does this happen?
Well, alcohol is one substance, and there are other drugs like this too, like, for instance, benzodiazepines like Valium and Xanax, that actually can have an amnestic effect, because essentially there are certain chemicals that are released in the brain during particularly interesting or new experiences, for instance, or emotional experiences. And alcohol can block some of those changes that happen when these chemicals are released in the brain. And so what happens is that it actually can block the formation of a new memory as a result. So sometimes you can even see after someone's had alcohol that they have better memory for the stuff that happened before they started drinking, but worse memory for the things that happened while they were drinking. Because what happens is that now you've lost all this memory for while you were drunk. And so the stuff that happened before is now not suffering from competition as a result. Alcohol is another interesting effect, which is that when you are under the influence of alcohol, you're in a particular mental context. So I think many people after like 3 or 4 drinks are in a different mental state than they are in their daily life, hopefully. Anyway. And so as a result, you can't access whatever memories you did form because you'd have to get back into that mental state again. And there's some evidence suggests that, in fact, if you did form memories while you're under the influence of alcohol, you can get better access to it if you're remembering under the influence of alcohol, which I don't recommend, but nonetheless, yeah. And there's other effects of alcohol. So for instance, it can give you these rebound things where it messes with your sleep. So even though alcohol can help you get to sleep, the sleep quality is terrible. You wake up in the middle of the night, and all those factors can lead you to have the next day, from all the sleep deprivation, among other things, your brain isn't going to function as well. In particular, the prefrontal cortex is an area of the brain that's important for allowing us to focus on what we need to learn. And it allows us to be able to reconstruct the context of past events so that we can actually pull up the right memories that we're looking for. And the prefrontal cortex is really shut down when we're in a state of sleep deprivation. So there's many factors, lifestyle factors. And of course, alcohol is not the only drug that affects memory. There are many others. THC, for instance, in marijuana can affect memory. Psychedelic drugs actually have interesting effects on memory. We're still trying to unpack all of them. They do seem to change plasticity in a way that can affect memory for while you're under the influence, but I think the effects are actually quite complex and interesting. But the effects on memory are probably the reason why some psychedelic drugs like MDMA seem to have an effect on traumatic memories, because often what happens is people retrieve these old memories, but you're also producing these changes in the ability to form new memories while you're retrieving these old memories. And so what can sometimes happen is the memory can become updated in interesting ways.
So I wish we could continue this conversation all day, but in true RI fashion, I'm going to put you on the spot to finish the episode. Not that I haven't been throughout this whole thing. So if there is one thing you want people to remember from this episode or the book, again, everyone should read it, what would it be?
I would say that the one thing I would want people to take away is that memory is not about the past. It's about the present and the future. And that we're constantly using memory to be able to tell ourselves everything from where am I at the given moment? What time is it? To things that are the big choices that we want to make in life. I mean, I know when I chose my career path, part of my key decisions were always based on what are the memories that I have of past times where I've been happy? What are the kinds of contexts in which I function well in, right? And so I really want people to think about memory as this resource that they can draw upon for making better decisions and for being more present and for choosing the kinds of life paths that you want to take. Because the thing is, it's going to influence your behavior. And if you're not aware of it, then memory's in the driver's seat, but you really just want it to be the co-pilot.
Excellent. Charan, thank you so much for joining us today. And thank you for such an incredibly insightful episode.
Excellent. Thank you.